Good afternoon. On behalf of Engineers Australia, I'm delighted to welcome you all to our Thought Leaders series, Fuse Your Projects, Physical and Digital Worlds, with a Smart Digital Reality. My name is Amanda and I'll be your host for today. Firstly, in keeping with our custom, Engineers Australia acknowledges the traditional custodians of the country throughout Australia and recognises their continuing connection to land, waters and community. We pay our respects to them and their cultures and to elders past, present and emerging. Before we get started, I'd like to acknowledge that today's webinar is being hosted with Engineers Australia's industry partner Hexagon. Hexagon is a global leader in sensor software and autonomous solutions. They put data to work to boost efficiency, productivity and quality across industrial, manufacturing, infrastructure, safety and mobility applications. The company's PPM division empowers its clients to transform unstructured information into a smart digital asset to visualize, build and manage structures and facilities of all complexities, ensuring safe and efficient operation throughout the entire life cycle. Today, we will hear from 3 speakers, followed by a live audience Q&A, and I encourage you to send questions through to our speakers via the chat box. I'd now like to welcome our first speaker, Distinguished Professor Feng Cheng. Feng is an award-winning, internationally recognised leader in artificial intelligence and data science. Feng leads multidisciplinary teams of experts, together with whom she has won major scientific and industry awards on the national level. Vang is the winner of the Oscar of Australian Science, the Australian Museum Eureka Prize 2018 for Excellence in Data Science, and the Australian Water Association's Water Professional of the Year, awarded in 2016. She is the 2021 winner of the Australia and New Zealand Women in AI Award in Infrastructure, and a 2021 winner of the New South Wales Premier's Prize of Science and Engineering. Please welcome Distinguished Professor Feng Cheng.
Thank you for your introduction, Amanda. It's my pleasure to talk to all of you. So digital age, the information is really at the centerpiece of the digital transformation. Today, I'm going to talk using some examples to talk about how to unlock the potential of data. Let me get into a few practical examples. If you look at this one, can you imagine every single dot on this map is actually one water pipe failure? So the water pipe failure, when it happens, it can create dramatic damage to society, to our properties, everything, you can name it. So if you're looking at this chart, and you have green lines and yellow lines. Green lines is a critical water main, which is by definition size larger than 375 millimeter or something critical under the critical infrastructure. You see the red dots are the failures on critical water main, and on the other side, the yellow line is non-critical, and the blue dots are the failures on those non-critical water mains. So this is the only illustration or painting of the whole picture look like. And this is only a plot of around 20 years of data in that area. You can figure out HCH is semi. So the background color is soil. The key question is, if you are a maintenance manager and if you are trying to stop the leaks and the breaks, just like you see in this picture, then what you should do. And by the way, the right-hand side of that picture is the real photo took a number of years ago, which is the water main burst to create the 13 floors fountain. Of course, it's not fun to have the fountain like that. If you can do left-hand side, which is do the repair and then to act more proactively, you can save even 90% of the money. And of course, reduce a lot of damage to the roads and to parks and to our properties and society. How to do that? So next one is looking into the approach we adopted, of course, working together with the Sydney Water on this case, which is looking into, how you utilizing historical data and also real life data coming from acoustic sensing to determine where the potential risk of leak and breaks are, and send crew to mediate those risks before it happens. So if you look at this chart, it looks a bit fancy, complicated, but the essential part, first thing is to get the priority on, where the risk zones or risk areas are. And of course, deploy or deliver sensors in those high risk zones. And then you can listen into those sounds coming from the sensors and utilizing AI machine learning signal processing, all those one to figure out the potential signature of the leak and identify whether it is a leak or sounds like a big or large potential of the leak. Then you send a crew, so the crew can be targeted on those leaks rather than hundreds of them, different false alarms, and then this can become well-maintained, proactive maintenance schedule, and that solution is actually the Australian Water Association Research and Innovation Award just a number of months ago, and primarily work with Sydney Water and UTS and some private partnerships. So drill down one little bit into this, which is the steps, the centerpiece starting from raw data. And then the data coming from, as we illustrated before, you have certain characteristics or attributes around your pipes, including material length and where they bury and how deep they bury, and if you have a wall thickness, all those ones even better. And the second is you have the environmental data, as I showed in the picture. You have a soil, different attributes of soil. It's more acidic or it's more aggressive, etc. And the last thing is about the operational data, for example, loading and the pressure in the water pipe, etc. So all those ones make sense to understand what's happening around water pipes, around leaks. And then we gather feature and the build model, and then eventually is going through the priority and the risk list. This becomes centerpiece to drive the proactive actions. Not only in the drinking water system, but also in the sewer system. If you look at those pictures, yucky pictures, is corrosion around concrete sewer, and hundreds of millions of Australian dollars wasted or used in maintenance. And particularly, it's unsafe working environment for sewer maintenance. And only once geared up all those masks and get all those training down to the manhole into the sewer, and that's more than enough if you do once. Not even looking into the social cost and the loss of time productivity that triggered by those sewer outages or spillage of the spill of the those guts into our nice environment. And if we're looking into drill down to this problem, for the engineers working in water industry, probably know a lot about this already, which is one big cause is around hydrogen sulfide H2S concentration on the concrete wall, and those is one of the primary risks to cause corrosion. However, we all know that we have limited observation around H2S concentration observation in the sewer network. If you look at the chart left bottom, which is the green lines are the sewer network and the dots are the observations of H2S. And utilizing those data, utilize the temperature, humidity, and all the other observations in terms of real observation of the sewer corrosion status. And we try to estimate the H2S concentration in the sewer network utilizing some smart modeling exercise. In this case, is a Gaussian model, which is part of machine learning, to estimate the corrosion level. And then, of course, I mean, in doing all those ones, it's never been 100% correct. It's always give you a certain estimation with we call uncertainty band, and to show some of them, for example, in the point A is really accurate, and then in the U part is you have high uncertainty. After we understand a bit of H2S concentration, then we look into how you maintain the chemical dosing, how you deploy a bit more sensors into different parts of the network so that you can collect more data and unlock even more potential of the intelligence into operating the sewer in a smart way. So this is actually the tools really using of compare the dosage, real dosage effect with the ideal or desired H2S concentration level. So we had enough in water. I'll give you another example is in power supply. This example is talking about how to utilizing the data such as the historical incident, incident record, site load, battery age, power distribution network information, battery capacity, outdoor temperature, etc., to help to minimize the risk of the power cutoff from those mobile power supply units. So you can see some of the high-level result is identifies 40% or more faults under the same spending of maintenance. This is a significant improvement in productive efficiency. And of course, more importantly, is reduce the customer impact on power outage. All those examples illustrate, we're starting from digitized information, which is data, and from that one to capture the intelligence, and from intelligence how to operate either your assets or your network or whatever kind of a business objectives or goals in a smarter way. Talking about smartness, we talked about data and the model. And next one, natural path, is looking into automation. How you can rely on data and evidence to put automation in process so that you can increase efficiency, performance, and quality. I will also use a few examples to illustrate some of the potentials. This one is a good work, won Government and Public Sector Solution of the Year Victoria Eye Awards 2020. It's a collaborative work with MB & Co. on identify the internet connections, the demand of the internet connections, so that we can make the connections hopefully connect the customer on time. So starting point is to understand the customer behavior, understand why customer become inactive. Of course, this or the desire comes from the current connecting problem. If you look at the right-hand side, is a chart, is an illustrative chart for a certain region to look into different suppliers and the connecting speed and the potential impact towards the customer. And based on that one, we produced a more accurate prediction model, which is a 30% more accurate to understand the customer demand, where they come from and which region come from. And then by that one is actually reduced 62.5% of the workload of manual work, because the automation is in processing, and a lot of the estimation of the demand is captured or is estimated by the computer model. And since then, it's delivered on-time connection as May 2020 is 96%. And then it's increased from 87% in 2019 to 96. And then for that period, the trial is successfully connected more than 2.3 million people into the network with a broadband. So this is only one example of utilizing the data and the model to put into the automation process. The other example I want to talk is around train network. And you can, train network, take Sydney as example. So tap on, tap off with your, Opal card, and you can get a customer get into a certain station information easily. However, you don't know the customer movement around the station. For example, Central Station, there's so many 324 platforms where customer move to, and those will have impact towards which how many people crowded on one of the certain platform, and that may cause delay of the trains, etc. And also what kind of variance of the customer each of the platform according to different weather, different time, different situation. Those information will be also very helpful to help to get the operations public transport on time. So you can see this is all the bounding box is actually using computer vision, which is one branch of the AI or machine learning, to calculate how many people on the different locations from platform to the stairs or escalators. Then particular on some platform which you have metro and normal trains running, and how people actually cross the platform at different interchange places. And by comparing the machine counted numbers versus some human manually counted numbers, you find that it's actually 97% or 90, sometimes even higher, is accurate. From that study, we can we can at least say there is a good way of making automation in place to automatically count the crowd in the station on different platform, so that will help to manage the on-time running and other key performance indicators in the train network better. The last example in this section, I'm going to talk about, this is on the inventory planning. We work with a computer company which as a service. So computer companies sell hardwares and also provide services to customers to maintain, your device running properly. For example, if your laptop failed, and then how quick you can get it repaired, it depends on one is technician, one is your spare parts. So in the past, a lot of planning is manually or somewhat from one spreadsheet to the other one. And what we did is get all the usage data, get the failure rate on different devices and different parts, utilizing those historical data to estimate the demand on the spare parts and put them into pipeline to get the stock into Australia on time, so that all the service can be maintained on time. So there's plenty of examples talking about the success in our society nowadays, from water to transport, from customer business, retail to different services. Next section of the talk, I'm going to talk more into how to building the digital reality and how to building our future-proof digital presence. Digital twin is one of the hot topic in in the current technology stack, which is looking into how to create a digital replica of our world, our assets, our network. This is around Sydney Trains network. And you can see we built this digital replica with real-time train movement around the whole network. If you're looking at these trains running with the bubbles, this actually is a train delayed. And the bigger the bubble is, and the more delay it is. It shows the real-time running and then versus the timetables. So you can flip it on and off to, if you try to focus on the trains which has delayed for operations, you can do so. And then, you can move your mouse cursor looking to different occupancy in the trains and then where they are going, how long delay they have. If you're tracking those delayed trains, you can see this is around CBD when you have 6 lines of trains running in parallel. And when it's close to those interchange station, the impact of the delay probably will be bigger. You also can compare the scheduled services versus the actual train services. If you look into this, the train is moving. Sorry, sometimes it's hard to see because the train network is so big, and you have to zoom in, really look into, this is delayed service, and this one is the scheduled services. So you can see how far apart the look like from spatial perspective. Next one is we can play what if scenarios. This is not real incident, but we play that hypothetically there is incident on St. Leonard's station, which is not Sydney. For people in Sydney, you probably can see that there's T1 train line. And if there's an incident happened, it's 9:20 to 9:40 on that day, it's the inbound, city-bound trains stopped. You can see the impact of the delay affect, how many trains and how big the delay is for that 20 minutes block. And you can also visualize that how long it will take to get the services back to normal. Now you see the train started moving through St. Leonard's station towards city. So utilizing all those digital tools as a what-if scenario planning and for disaster management, for community resilience test, etc. So when we're talking about data, we're not only talking about data from one sector, like transport. In this case, we integrate the data coming from water as well. As I said, we have a lot of water mains across city. Those green lines, the previous one, or the water pipes. And this one is air quality. So it's different, blue dots, different observation station for air quality. And then, of course, with more and more data integrated to the platform, this one is a car park. You can see the occupancy and you can see the potential availability of the car park. So this kind of a digital replica is integrating more and more reality, which is through different data stream, and that helps us to manage our city better, manage the city planning and operations. Of course, you can use that as a future proof for certain sectors, like doesn't matter is the transport sector or in the other utilities. And this is a snapshot of the 3D, the real 3D environment. This is all has been imported and rendered. It's just you need a bit of computing power to do that. So yeah, and then I can show you this is as a lot of the future that we're looking forward to. So if you look at the bottom line, we already integrate the transport data, 3D city modeling, water pipes, parking, population movement, etc., and working on bushfire and some flooding or emergency management data coming out of that. And the key of this kind of digital future is you can play scenarios, do what if type of a planning, and then put in the best decision, which is under we call multi-objective optimization to hit the business target or hit some of the criteria you try to hit and get the best decision out of that. I've been illustrating a lot of examples from data usage to modeling to automation to our digital future, including digital twins. But a takeaway message, starting your digital transformation journey today, don't worry about, whether I have enough data, I got a quality of data, all those issues is if you don't start today and you want to have tomorrow and the future. And of course, once you start unlock the potential of the data and get utilizing smart modeling, particularly AI and machine learning, and even consider some of the changes to conventional business models and process, and automate as when it's feasible and applicable to increase efficiency, productivity, eventually build a future-proof digital reality ecosystem. Really looking forward to working with all of you and our society to make this happen. Thank you very much.
Thank you, Feng, for your presentation. I'd now like to welcome our second speaker, Ross Porter. Ross is an electrical solutions and support engineer and a senior level director in the engineering and construction and oil and gas business, with over 30 years' experience. Ross has served in a variety of technical and progressively responsible managerial functions over his career in the EPC business. Currently, Ross works in the Hexagon's Asset Lifecycle Intelligence division, with attention to the project execution portfolio of solutions. Please welcome Ross Porter.
Hello, everyone, and thank you, man. It's good to be with you today. My name is Ross Porter, and I'm with Hexagon, specifically the Asset Lifecycle Intelligence division, ALI for short. Some of you might have known us previously as Hexagon PPM. So today I want to walk through a bit of the Hexagon vision and then talk a little more specifically about the ALI strategy. So I'll start by saying advances in technology, specifically in the digital reality space, have reached a point where it's blurred the difference between digital and reality. So I think it's fair to say these advances promise to accelerate productivity for the industrial facilities And this is at a time when economic and environmental sustainability is a must for us. We need to adopt technology faster in our industry. I think we can all appreciate that. I think Hexagon's ultimate mission is to empower autonomous, sustainable future by putting data to work. That's it in a nutshell. So there's a video here, and it will continue to play, and it'll show you some of the space that Hexagon operates in today. But this slide really gives you a view into our vision for an industry that will be transformed by autonomy and powered in many cases by Hexagon innovation. This innovation powers our technology, providing greater strategic and hopefully measurable benefit value to our clients. It has fueled our growth and put Hexagon in a leadership position to help with the transformation to the digital reality. We work closely with our customers and our partners to deliver this. So, for instance, Hexagon technologies are driving efficiency for more than half of oil, gas, and chemical processing around the world. But Hexagon does go further than the industrial facility space. We're a recognized leader in public safety, where our solutions protect 1 billion people around the planet. Or in construction, where Hexagon solutions were key in the building of the Burj Khalifa building in Dubai, the world's tallest building. And I'm betting that you, most of us here, have encountered Hexagon technology, some of our manufacturing technologies, because you'll find them in 95% of the cars, 90% of the aircraft, and 75% of the smartphones used worldwide. So, I think it's clear we need a new approach to building and operating industrial facilities with some innovations that are fueled by modern technology. So, the Hexagon unique proposition, value proposition here is the feedback loop between the real world and the digital twin. That's where we'll apply our core competence and technologies to ensure that we can maintain that as-built environment, if you will. We do that in several ways. Reality capture, this is capturing of the physical world data by any means of a number of technologies. We have positioning technologies that will help locate, track, navigate, or control anything, anywhere, quite frankly. Design and simulation, where we replicate real-world scenarios in a digital environment. And location and intelligence, active geo-referenced intelligence of real-world locations and situations. Also, autonomous technology, where we can automate any task or workflow, enabling action without human intervention, and hopefully, eliminating error and keeping people out of harm's way. So, Hexagon delivers this value based on these 4 primary pillars. And we have these really to help us put the vision in context and have a common language and a beginning point, a shared vision, if you will, to communicate with our clients to help modernize these asset-intensive industrial facilities. The pillars are, again, back to data, unlock the potential. We have to gather the data. Without the data and the intelligence they bring to the digital world, we're not going to have a fully complete and usable environment. We like the term digital your way. This is really important, I think, in that all of us have ecosystems, processes, systems. We've trained our people. We execute in a certain way, and our intention is to meet you where you are. So the goal is not to force feed you, but to come alongside you and help you down that path to the digital reality. We want to automate where it matters. This is important, again, to eliminate error and to take drudgery and add productivity, but to protect people as well from environments that we don't want them to be in by some of this modern technology. And of course, sustainability, right? Both economic and environmental. This is our goal at the end of the day. We can't ignore it, and it's high time that we brought it into the industrial facility space. So, now I start to talk a little more about ALI strategy and some of the things that we're doing in this space. We've coined the term smart digital reality. This is at the cornerstone of everything that we do. It supports a digital backbone, if you will, a common data set behind it, and allows us to capture that real-time data or existing information. If you're building a greenfield facility or you are in a brownfield facility or an existing operating plant, we have to capture that data. We have to move it into the backbone and then make it available through all the technology and analytics to allow those on the other side to visualize and analyze and then provide that continuous feedback loop again, all to deliver value, right? Safety, quality, productivity, efficiency. It's key that we deliver value. Otherwise, it's a nice tool, but it's not really perhaps hitting the mark for you and your company, and that's most critical, of course. So let's drive down a little bit further. Again, back to the value proposition. We start that with every mission and goal. So I'll peel back the onion a little bit. Everything that the ALI division does is around digital projects and digital assets. You'll recognize the plan, design, execute, operate, maintain, and secure. And we can go through the life cycle of any project or asset around project planning, project feasibility, concept, detail engineering, supply chain, fab construction, into operational excellence, process safety, maintenance effectiveness, and sustaining engineering, not to mention cybersecurity. We bring into the mix, the underpinning here is, again, innate technologies in that digital backbone to provide, the level of productivity that we're looking for around interoperability, connectors, again, reality capture, the visualization, and all the analytics that go on behind the scenes. Other autonomy enablers around the connected worker, of course, cloud and the SaaS offerings, artificial intelligence, most important, and then robots and scanning technology that we believe plays a key role. So, I like this slide because it helps put thing in perspective, right? We all have smartphones or tablets today, and we organize those smartphones with the apps we like on it. We like to hear the sounds that we want to hear on it. We organize it in a way that helps us in our personal lives on a daily basis. And I think we can all relate to that. Our intention is to support that very environment. I think we have to today because it's really what people are used to and what people expect. So again, we start with the data input, and that's reality capture and project design capture, sensor data, operational data, all goes into that digital backbone and is consolidated there, right? And put into context. And AI plays a heavy role in that space to allow us to take that very large amount of disconnected information and to correlate it and to make sense of it and allow it to help you in your plan, design, execute, operate, maintain, and secure environments. A vision that you're the construction manager or design manager or even the guy in the field that's in construction and craft, and you have that smartphone and you're trying to figure out what work package you're about to construct today. Putting information in front of you real time in the role you're in the right context, we believe will drive then, of course, to better decisions, faster decisions, more accurate decisions, and drive the outcomes that we're looking for. And again, around safety, efficiency, quality, and productivity. So we believe this is a vision to go forward with, and we're all in. So I'll talk for a little bit about this slide, and it's about digital projects, and this is the space I play in mostly. Again, along the top of this, we call this the snake slide, right? But this is a digital backbone, and all the functional bits and pieces that feed into the digital backbone. Again, we recognize that everyone has tools, processes, and people that are aligned to the way they do business across that life cycle. And we're tool agnostic, for example. We are not trying to force you into a tool set. We're trying to take the data and bring our technology alongside what you do and allow us to do much newer, better, fascinating things with it that we've never really been able to do previously. And then along the bottom, we have a lot of the functional areas that we, group in order to bring our technology to bear. Common administration. Let's talk about plant nomenclature or operating facility nomenclature. This is a place to manage that. I want to look at a project. I want to look at 3 projects information. And I want to query. And I want to understand, what's gone in the past, or I want to see operating information. Common environment by which to do all that. We talked about vendor documents and drawings. I've lived in the EPC world for a long time, and fully 60% of the information on a project is external. It's not generated by a project team. So we have to bring that information on and make sense of it and put it in the context in order to do things with it. We do that through autonomous data and graphics checks. This is where we manage the consistency, what's missing, all the things you need to do to have an interoperable and connected data source. And then, of course, you can interact with it, visualize it, collaborate with others, interrogate it to your need, whatever suits your particular position. And then I bring up shutdown, turnaround, and outage. This is a space that we're spending more and more time in, and we believe that it's been an underserved industry, and we think we can bring a lot of productivity enhancement in this space, and that's something that we'll be driving to deliver. This backbone, it drives through the digital project, and as you can see with the arrow, into the digital assets world. Now, we're not, this can be as simple as a handover to support operating and maintenance systems on the other side, for example. So we're not requiring you to use our backbone. It certainly does work easier if you do so on the backside, and we intend to position it to where it's easy enough to put in place, again, with your existing tools, technologies, and people and processes in order, that it will be simple enough for you to take on and utilize. So again, this goes over into the operating world, and this is a continuous loop, right? We talked about the feedback loop. This runs down and it runs back, and these arrows on all these slides here run both ways. So if we talk about the life cycle of an operating plan, if you will, around operational excellence, process safety, maintenance effectiveness, notably sustaining engineering again, and cybersecurity. Likewise, we'll apply technology in groups as we've shown on the bottom around the connected worker, geolocation, interoperability, of course, the integration of all this particular information. Again, visualize, collaborate, and interrogate, and then apply robots and scanners and other bits in order to fully realize automation and utilize this data that we've taken all the time to collect and make sense of. So I'll run to a video here, and it gives you a bit of a vision on how we see the world, right? We have drones and we have Spot. If you're not familiar with Spot, it's a drone, a dog drone, and we're actually working with Auburn University in the southern U.S. and collaborating with them on outfitting Spot with some of the Hexagon technologies. This drone, for example, is detected a cyber intrusion, and it's going to highlight that to the right people and see that it's resolved. Here we have Spot, for example, and he has scanners, he has gas detection, he has noise detection, vibration detection, any technology we can bring to bear and hopefully keep people out of harm's way in the process. So Spot has detected a high vibration area here, and we're going to bring up the asset information and have a look at the history and the health of this. And we're assuming here or concluding here that the bearing is failing and needs replacing. So we'll have a look at that part and look it up and decide where to get that assembly from. We see here that there's no inventory available, so we say, hey, we got to 3D print this. And the reality is 3D printing is here for today, and it's something that I think we're going to see more of and start utilizing. So I think this is not a far-fetched scenario at all. and then we replace the bearing, and of course then we see that the plant is back to operating efficiency again. So I hope this is maybe enlightens you a little bit, give you a little insight into our vision. This is, Hexagon and Hexagon ALI are all in to these spaces, and that's where we'll spend our time and our energy, spend our money, make acquisitions, and anything else we do. So thank you very much for your time today, and I'll turn it back to you, Amanda. Thank you.
Thank you, Ross, for your input. I'd now like to welcome our third and final speaker, Guy Mason. Guy is a chemical engineer and an MBA graduate with 15 years of professional experience in various disciplines within the chemical engineering industry. Guy specialises in engineering software development, petrochemical plant design, polymer manufacturing plants, semiconductor fabrication, and a project manager at a chemical pilot plant. Guy uses his extensive experience to support Hexagon's clients in their software product management and implementation, process project management, digital transformation journey. Please welcome Guy Mason.
So hello everyone, and thank you for the introduction. Now I'm actually kicking off from what Ross discussed previously. I'm going to continue with this slide, and now I'm going to drill down into the next phase. The next phase is more of going a bit below the high-level introduction, the high-level vision overview that Ross gave, into what actually project delivery is, how the engineering departments connect, what information flows in, and how at the end it would look like in the actual end result, in the actual digital twin. So a bit of how kind of the information or the data flows into intelligence, flows into visualization. The discussed backbone is actually connecting all the different tools into a consolidated place where the information flows. That information in turn needs to get analyzed, needs to get consolidated, different same properties from different points of view. For example, if I take a pump, it has a point of view of where it's located in the process diagram, how it's controlled through the instrumentation, as well as how it is connected to the plant electrical grid. All those, all that data needs to be consolidated into one place and has to get analyzed, and then that information can then displayed visually for the end users to view and take actionable decisions on that information. So how would that look like? So for that, I've kind of prepared a general video, so I can guide you through how it looks like. This is currently how a digital twin looks like within the Hexagon suite of tools. And we'll start with the first one. So first of all, our biggest thing, as discussed before, is to make sure that this is accessible from anywhere. All the stakeholders can have access to the data, can view it. In this case, it's viewed on top of a browser. The browser is scalable from stationary devices as desktop and laptops, and more mobile ones like tablets and phones. So once that happens, all the data flows into that digital backbone, into the information management hub. The data is then consolidated. You can see this is an integration place where all the different control deliverables flow in. If I go into a bit deeper, you can see these are all the different deliverables flowing in from the separate departments. There are process diagrams, like the process and piping diagrams, the loop diagrams, and so on. All of them are flowing into one place, consolidated, and made sure that then in the next flow can be visualized. So The first thing that you would visualize is at the beginning of the design phase, the schematic tools, for example, the P&ADs in the process department, the loop drawings, and the specification sheet within the instrumentation department, as well as the single line diagrams within the electrical department are being created. So you can look at the individual deliverables one at a time, or if they're all consolidated into one backbone, into one thread, then those are hyperlinked. For example, if I'm going from this process diagram and I want to get more information for a separate item, for example, that control valve, I have access to additional deliverables. Those deliverables come from other tools. For example, in this case, they are coming from instrumentation. You see the spec sheet of that specific control valve that you have seen in the pipe in the P&AD. You'll be able also to see that loop diagram. So it gives you a different view of that control valve, but from the instrumentation department. All of these are connected. The different properties, the characteristics of that specific valve are all harmonized and aligned between the process diagram, the instrumentation specification sheet, and the loop diagram. Once you know and you can analyze and understand the information on that schematic 2D environment, you can go into the 3D model, expanding your vision on that specific information. As you can see, everything is, again, it's linked. So that vessel that I viewed in the P&AD is now actually highlighted in the 3D model. So from that item, I can zoom out, can see the entire plant that I'm looking at. I can see all the different information that is flowed and is tagged. And you can use that information that is digitally put inside the 2D tools and the 3D model and combine them into one. In this case, you can actually visualize the piping, the systems, the piping orientation. You can do an overall clash detection, and you can get a real feel of the model. Moreover, that information can actually give you the system readiness for the next phases. Let's say, what's the design status? So you can highlight all the design statuses and filter by the ones that you're most interested, and see if a system is ready to go to the next step into construction status, and of course the material availability. You really don't want to go into construction without knowing that all those specific materials are on site and waiting for that construction to begin. So when you get that visual intelligence and you understand the model, you can go into the next step, which is construction. In this case, you can see the construction and commissioning phases. You can see the commissioning. You can see exactly what you need to block off and how do you need to test for your dry testing and wet testing. And moreover, you can actually go and see before you actually go and construct. You can see the latest construction deliverables to make sure that that construction deliverable was already reviewed, tested by the design department, and the construction managers and operations and foremen have reviewed it. That deliverable also, you can see it's already showing you that specific isometric for construction, as well as its connected bill of materials, all the materials you need to construct that piece. So through one specific flow, we have reviewed the design phase, we reviewed its readiness for construction, we know its outlines and space and how it's constructed on the space. You can clash detect as well as plan for your commissioning and construction activities coming next. Thank you.
Thank you. Thank you to Guy, Ross and Fang for terrific presentations on today's webinar that focused on fuse your project's physical and digital worlds with a smart digital reality. It's now time for you to get involved, and please ask our speakers questions via the chat box. And if you could include who your question is for. Also, I want to thank everyone who put through questions when they registered, and we might begin with some of those. Feng, I have a question for you. It's quite a lengthy question. It's coming from Alexandra in Western Australia, so just bear with me. Alexandra is asking, there are many specific software solutions that just need to be integrated for a unified digital twin and simulation modelling control solution. Do you find your biggest obstacle to digital twin adoption are the experts who can't let go of their specific digital software as they fear that a new model, which is more broad, solves many problems interactively as a complex system, i.e. lack of trust, or think it's a black box? Bang.
Thanks for the question. It's a fantastic question. Okay, if we're looking into any software or any technology adoption, trust is absolutely a central issue. To address those ones, I think it's a complicated process, and sometimes even you named as a change management. So of course you need to identify some of the use cases which is really can exhibit the benefit of the new technology. For in this example, we were talking about digital twin, and the data fit is important. Particularly, you're talking about complex systems integrations, and where you actually get them those data fit, whether they transmitted or transferred correctly from one legacy system to the new digital twin or whatever platform. And then how to establish the business as usual process so that you can shift over from you search around the 5 different software platform to get information versus you come to one, and how that business process will look like, and including troubleshooting. All those ones are important steps. All those ones eventually is building the trust between the users and the technology, and then hopefully the use case validates the data when users using new software or new platform achieve the higher efficiency or productivity or whatever things you can't do in the past. That will absolutely, amplify that trust between the users and software. Thank you.
Thank you, Feng. Thank you for that. And Guy, just bringing you into the discussion, we've had a question that's coming from Huda, and Huda is watching the webinar from the Middle East. Good afternoon to you. Huda's asking you, Guy, is it worth trialing different technology platforms all the time, or just keep it simple?
The way you actually structure it, you have more information. The technology advances. There's new products. There's new technology. Ross showed you Spot. Ross showed you there are different levels of drones. So you can keep it simple. I think it's more not keeping the technology simple, but keeping the user interface simple. Having the end user using the technology the way that they can use it, the way it's apparent, it's intuitive, and works for you. You can same look at our mobile devices. 10 years ago, if you went simple, you had a very simple device. Today, although the devices have been jumped many generations in the few 10 years that they exist, you can see they are more elaborate, have more capabilities, but still the user interface is kept simple. So I think we should take advantage of the new solutions, of the new technology, simplify their output and make the understanding a lot more easier. And that makes the implementation and analysis piece that much more easier. So the technology is there to facilitate your the capabilities of your requirements, and you should use as much as you can of it.
Thank you, Guy. And Ross, looking to bring you into the conversation. So this question has come in from Mahinda in WA. And Fang, if you could answer first, and then Ross, just come in with your thoughts. Mahinda is asking, why do we need to change to the smart digital way? Fang.
Try to find my unmute button. Oh, that's a $1 million question. I think it's so nowadays we move into digital era, and in digital era, the centerpiece, as I said, is the information. So information in the digitized format, and then the decisions can be evidence-based, and then decisions can be real-time and or more responsive rather than you review the spreadsheets afterwards. So, of course, there are a lot of other benefits as well. I'm sure Ross can fill in. Overall, it's utilizing digital transformation, of course, turn our current operations into digital reality, and then that will facilitate a lot of productivity, efficiency gain, and more safety, more secure. Yeah, you name it.
Ross, your thoughts?
Yeah, sure. I'll add to it. Good question. I think, the smart digital reality, as Hexagon has coined the phrase, we believe it is our next best opportunity to have an impact, in particular in the industrial facilities industry, but any industry where we're trying to take decision making and to the next level, right? Without the real time data and the feedback between the real world and the digital world, we're not going to be able to do the clever things that we know we can do if we have the data. It's all about getting the data. Bottom line, if you don't have that, then it's certainly going to be difficult to move the needle, if you will, right? So I think it's important that we get to this smart digital world and see what we can do there. It doesn't mean we eliminate people from that smart digital world. It means we give them better tools to do their job.
Thank you for that, Ross. Back to you, Fang. We've had a question that's come in. It's a great question from Robert, and Robert's watching us from Queensland. Good afternoon to you, Robert. Asking you, firstly, you, Fang, and then Guy, your thoughts. What end-to-end fully integrated digital solutions currently exist, and what are they like? Thanks, Fang.
I know it's flipping between the questions, send it to the screen. Okay, I guess this is a broad question, but an interesting question. The solutions does exist, depends on what sort of industry you are working in. And then, I'm more than happy to give you a bit more pointer later on if you need the details. But as I mentioned earlier, the end-to-end solution is coming from your data as the starting point, and or your digital assets as the starting point, and the end is the action that you can take from all the process through data and analysis, intelligence, and then modeling, validation, whatever you need, but you can take business actions. Those actions could be alert. Those questions could be you change the gears of something or change the way you're dosing chemicals, etc. Hope that'll give you a little bit of hint, but it's a broad question.
Thanks, Fang. Guy, do you want to comment on that?
Yes, thank you. I just want to highlight, you saw already in the presentation an end-to-end solution. Of course, it depends on what you define an end-to-end. So in the case of today's demo that I just showed you, the end-to-end, the starting point will be the engineering project, and the end would be the construction and handover to operation and maintenance in a facility. In this case, it was a gas facility. So you can see that the beginning has been that in the Hexagon suite of tools, it starts from the beginning, from the process design to the instrumentation design to the electrical design, goes a step further to the overall 3D model and paving the lines to construction. So you can see that the whole end-to-end start from the beginning of the design all the way to construction. Of course, you can take the end marker and push it all the way through and add handover and how the information flows from the design into operation, into the control room displays, into the shift management, into the information management, and procedure management. It all depends where the end-to-end you put it and where you think it's relevant. But I can tell you that all those technology already exist, and all those are already becoming into one solution that are accessible from all the stakeholders, as I've shown before.
Thank you, Guy. Ross, over to you. We've had a great question that's come in from Sharia, who's watching from the Middle East, and we really have got an international audience today. Sharia is asking you, Ross, what ramifications do you foresee by fusing projects' physical and digital worlds towards climate goals? Russ.
Good question. Well, I alluded to it a bit in the presentation, but I think by having the digital world, we're able to do, again, things with data that we've not really been able to do before. We have access to, the carbon footprint, right? And let's take, for example, in the design process, you can alter design to come up with the smallest carbon footprint, for example. And really, you can't do this if you don't have access to that information. And I think this is going to change the world. I think eventually, we'll be required to monitor the carbon footprint on any new facility and quite frankly, justify changes to an existing plan and be able to quantify a carbon footprint for that particular process change. So, maybe one small example, but I think it's upon us now, and I think we're all going to have to manage it.
Thank you, Ross. Does anyone else want to comment on that? With the climate smart. Yeah, we'll move on to the next question, which is talking about how professionals will work in the future. And it's a great question that's coming from Peter in the ACT, asking you, Feng, how can you see the emerging AI ML technologies impacting how professionals will work? Is the concept of augmented decision-making near-term or well into the future? Thanks, Peter.
Thanks, Peter. So the question, augmented decision-making or augmented intelligence, this is absolutely something I could say is an interesting way to look into how we work. This is not only to professionals, of course, professionals is in that ballpark, probably more impacted. This is actually no difference with the concept we always say human-in-the-loop design or human-centered, AI stuff, which have core parts, which is first user defined or use case defined or use inspired or use problem driven, whatever similar words you're using. The second one is you have analytics or data driven, evidence based driven. Then you have a certain part which is automation in that is either AI or machine learning, whatever based, is you have a ability of self learning, self correction, etc. I think it's changing in terms of professionals how work. I think it's changed significantly from a training perspective. I would highly encourage people to take more focus in terms of STEM, which may not be a focus for some professionals in the past. The second one is all those decision-making tools nowadays. It's actually no difference with any tools. In the past, maybe the tools is a little bit how could I say, a little bit low level, for example, spreadsheets. And now it's more like the crunching engine at the back end, which they can take some input and do updates and then give you some decisions. But eventually is human driven, the design and the human driven the decision point where and when human make decisions, where and when machine make decisions. As long as we have trained our mentality to working along those lines, I think it will change the practice. However, it's a adaptable process. Thank you.
Thank you, Feng. Thank you for that. We've had a question that's come in for you, Ross, from Mark, and Mark's watching from New South Wales, asking, Ross, what are the key factors to consider when industry end users are planning a roadmap migration plan for their plant and infrastructure assets to meet a future-proof, digitally integrated goal? Thank you, Mark.
Yeah, good question. Well, I think the first thing I would say is keep it simple, right? You know, it's like I said, everybody has an ecosystem in place, and when you upset, disrupt your current way of doing business, it's difficult. You have to ease these in. Now, I talked about meeting you where you are in this digital journey. I think, again, to hark on the point, the first thing we have to do is collect information. And as long as we pay attention to that, then we'll have at our fingertips things that we can do that we never could do before then, right? But, consider an industrial facility. Not every operator has a 3D model of this plant, right? Most don't, in fact, because it takes time, money, and energy to maintain those. So, alternatives could be starting with scanning and using technologies like AI to extract relevant information to enable you to keep that scanning as built, put it into context, which is something that we would like to do with our digital backbone. If a scan is just a scan unless it's put into context. We've got to know where it is. We got to know the information on it, and that is your 3D twin. Then at that point, and again through the use of technology, if we can infuse that with the right data and support it with all the external information that we need to act upon it, then we're able to do what we want to do. Again, start small. Take advantage of the bits that you do have and grow from there.
Thanks. Thank you for that, Ross. Guy, back to you. We've had a question coming from Sujan in Asia asking you, Guy, when we work as a team, different people have different levels of capability in adopting new technology. How do we address this issue? Guy.
Thank you. So actually the question comes into play after the previous question. So as discussed before, many people from different departments, different disciplines provide data to the same digital twin. So it's similarly looking at people with different capabilities or different roles for that matter. People in construction, people in operation, people in design, project management. Each one has a different role. Those are always one of our objectives within the tool is to make sure that every single individual have access to exactly the information he's responsible for and all the information that can contribute to his work and not overclutter him with information he does not use. So all of the tools, all of the technology have role bases. So when you log in to a system, you log into your machine, your work machine, your laptop, it already recognizes who you are, what your role is, and according to that role and information, it will give you information that is relevant to you and your work. So thus, it's simplifying your view and only giving you things that are actionable, while on the other hand, making sure on the back end that everything is connected and correlated, that everybody sees that same level of detail from his own point of view. So the way you do it is you actually use the software capabilities and the role-based accessibility to the data. So everybody sees what they need to know and what they need to action their work on.
Thank you, Guy. Thank you for that. And just staying with you, Guy, questions come in from David. David's asking you, Guy, Are digital twins like projects, vulnerable to disruption by changes in project direction, i.e. requiring significant work to redo the digital model underpinning the twin? Thanks, David.
So yes, all project and actually all life are subject for things that that change the expected path. Latest and most relevant of that is COVID. Nobody expected it to come, but it hit us, and it hit the entire industry. You have two options. That certain change would happen anyway, if you have technology or you're planning for it or not. So what you do, you use with your own technology, you adjust the digital twin, you adjust the nature of the actions that you need to do, and to make sure that all of them combine. If you don't have that technology and that information is not combined, then you have more chances of making mistake, taking rash decisions, and missing relevant information. So although things do disrupt the project, and they always do, and things need to be rescheduled and need to be reviewed, the technology will help you to make it faster and more efficiently. A good example for that is during construction, you are implementing construction packages, and that relevant material that you need for that construction is not there. The more you know of it upfront, let's say there was a problem with the delivery, there's a problem with the delivery trucks, there was a problem with a plane that was delayed, and that specific material is not on site. Through your information of the digital twin, you can see what different construction package that specific material affects, and what can be done in parallel while delaying that specific package. So work continues to progress, although if you and things continue to move forward, and you can mitigate that risk. Although when for example, you did not have a technology and you did not know where that material is delayed or not, you would try and start that construction piece. You would see that there was no materials. Construction people would stay idle on site, and you will start moving a lot faster to expedite material and pay a lot more for that material, or reorder for that material to arrive. So you're losing schedule, you're losing money, which affects your project delivery. So digitally, information that are digitally available and integrated within the system will save you schedule and money.
Thank you for that, Gal. Thank you. Question for you, Feng, that's coming from James. Good afternoon, James, asking for the train passenger flow analysis in your presentation. From the ML algorithm that performs accounting, what are the outputs of this for an operator? Is this change in Opal Gate's direction, change in train door open times, and look at prioritising particular platform extensions? Feng.
Thanks, James. Great question. There's a ballpark is the two sides of the coin. One is longer term planning. So longer term planning, including what you said, platform design, for example, also timetable. So how you plan the timetable properly so that you can get the people dispatched from certain platform within a time. So, for example, your door opened, how long you need to open the door for. The second fold is the real-time response. Real-time, for example, certain stations, the door open-close time is very, very critical. Take Town Hall as example. If you live in Sydney, that's one massive interchange. And the Town Hall station, the door close time is so critical to the whole network on-time running. If you observed the too many passengers onto that one, so you needed to have some certain procedure or process to, distribute the flow, not to let them to all into the platform. Otherwise, your door never ever going to close. Just an example. The other one could be, whether you need extra services to take people away, or under circumstances like emergency evacuations, how many replacement buses, etc. you need to at a certain exit or certain platform. So many things that can be done. Even very critical is at the station is people management, right? Is crowd management. Try to send people to the places they want or as close as to the places they want. Thank you.
Thank you. Thank you. And just staying with you, Feng, we've had a question come in from Helen saying, could you also access mobile phone signals to include analysis of the movement of people? Feng.
Yes, absolutely. But this depends on the availability of the data, right? So also the resolution of the closeness. So some different mobile signals or providers release data in a different way to say, okay, some of them you can measure 5 meters, some of them maybe you measure 100 meters, and then depends on your application and it depends on the data license you have. You can construct a different usage. But simple answer is absolutely yes. You can use mobile phone. Was under all the safety, security, privacy, all those legislations.
Thank you, Feng. Ross, question that's come in. My company is in the very early stages of our digital transformation journey. Where would you recommend is the best place to start?
Well, interesting question. I mean, I think I said earlier, you want to keep it simple, of course. Best place to start, I guess it depends on your level of technology used today, right? Do you use modeling tools today? Are you just taking paper drawings and trying to make sense of those? In the case of paper drawings, companies like Hexagon have technology for scraping and digitizing, if you will, the information off of drawings. Where in the industrial industry, we find that to be a place where many people are at the moment. They have drawings that might be quite old, or perhaps even in a new plant. If all you're taking is deliverables in a 2D format, then you've got to get that data from those drawings. So I'm guessing that's probably where you're at. And if you apply some of the technology that Hexagon has, for example, and pulling that information, it's a great place to start. You've got to get to a point where you can keep this information evergreen. I mean, that is the premise of a digital twin, and you go from there, right? It's not a short journey, but it's one we certainly have to start.
Thank you, Ross. Fang, a question coming from Sujan asking you, I'd like to know how to apply the same technology in a manufacturing environment where thousands of people work and how to optimize the workload for all of them. Fang.
That's a challenging situation, of course, because you've got thousands of people, and I presume that you have a very different workload. A different type of work. So I guess the key starting point is understand the categorization of your job type of work and the workflow, and then whether you can measure the workload in an easy way. The last thing pop on my mind is you probably need to consider your optimization criteria. The criteria, of course, the efficiency is one of the. I mean, obviously will be one of them, or timing, or and then some of the other ones is the safety stuff. Maybe you can't compromise, so you have a different criteria in your optimization, and you have a bit of processing sequence. If you get some insights into those ones, and then the rest, I think technology can handle. Basically, you can you can build real-time planning or scheduling system, for example, or whatever name you call it. is basically you have workforce at your in front of you, and you have certain tasks you need to finish at a certain time with a certain cost function, and then smarts can be applied to juggle those scheduling or arrangement of your workforce to achieve the maximize the output or outcomes.
Thanks, Feng. We've had a great question come in from Heather to you, Ross. And Heather is asking you, Ross, it seems there's a large gap between where many local governments are in terms of asset management, where the asset data might still be in paper form, and what they can achieve if data were readily available. Therefore, do you have strategies for efficiently and cheaply collating all the data? Thank you, Helen.
Yeah, sorry, was muting. Yeah, I think that's a great question, and I kind of alluded to it before that we do have drawing scraping technology that we can take advantage of and populate a system with actual data related to a drawing. I think cheap is the key, and you mentioned that. I like that word because we believe this is something we have to make available to to anybody, but it has to be cheap. It has to be obscenely cheap, actually. And the reason we support that is because, again, we can't do all these great and wondrous things with data and tools and analysis and the analytics and the correlation and the comparison and all the bits we can do if we can't get our hands on the information. So it is our goal to make it actually insanely cheap in order to reach that point.
Thanks, Ross. Thank you for that. Fang, question from Aidan asking you, what cloud platform software was used to build the city digital twin that you've showcased today? Fang.
Thanks, Aidan. The digital twin platform we built actually we built using simple software, so simple tool like Python, Java. We actually build ourselves. The reason to build is to try to provide the best, interoperability, or at least can plug into any of either the visualization or linked to any digital assets, detailed attribution, those platform. From cloud perspective, we use a specific cloud, but I don't think this is restricted to any cloud environment. As long as you allow them to have, you allow your data and model be stored and to be accessed frequent as you want. There's no limitation on that one. We tried a different platform as well. So, yeah, hope I answer your question. Thank you.
Thank you. And we're rapidly running out of time as always, but I have a question here. Maybe Guy, you might want to pick this up. What are you seeing from customers as examples of automation? Guy.
Okay, I'll try to think of a couple, but the first one that comes to mind is doing an engineering design plant. What happens in many cases is electrical cables are run and need to be connected through the entire plant. That specific task is an issue. Although you use a 3D model, the cables are not always looked at and are revealed from the electrical point of view. So when you have a digital twin, when you can connect all the cables, all the panels, all the junction box, all the electrical consumers in a 3D model, you can actually route all the different cables with exact measurements, with taking the exact length of the cables from where they need to go, and those lengths can then be calculated into the drums that they use, and the exact drums to be bought for that project. Previously, when things have been done in silos, the electrical people would have calculated the cable length through general arrangements. The calculation were not exact, and the plant kept on changing. And what happened is they bought more drums, more cables, which added a lot of cost to the project. So with combining data from different threads, like the 3D model and the electrical discipline and the instrumentation discipline, which also uses electrical requirements, you can actually fine-tune the requirements and save a lot of costs to the project. So that is one. Another thing relates to the example I gave before with materials and construction. Once you link those two together, you can actually have more visibility to the actionable construction tasks that you have. Again, saving money and schedule to the project. There are a lot more examples. These are the two that first come to mind.
Thank you very much. And we have run out of time. So if we didn't get to your question, we apologise. I'm sure we'll be doing much more on this topic in the future. Please join me once again in thanking distinguished Professor Feng Cheng, Ross Porter and Guy Mason for their time and presentations today. I'd also like to thank Engineers Australia's industry partner Hexagon for their support. Please, as always, if you could complete a short feedback form, which is linked in the description box below, it helps us improve and plan for future sessions. Thank you again for joining us, and we hope to see you at our next Thought Leaders event. Good afternoon.